Hello and welcome back to the shop. And as you can see, I'm wearing my Keith Fender stuff that he had given me when I was down there. He also gave me a nice Turn Right Machine Works sweatshirt, hoodie. And maybe some of you guys that didn't see the other video, he burned out a really nice sign for me on the plasma cam, and I'm going to varnish this just so it doesn't rust. I'm going to leave it natural metal color, and we'll hang it up somewhere prominent in the shop, and we'll probably make this into the shop logo. Just haven't necessarily figured out how to do that yet, but we'll figure something out. So today's project, we're going to be making this right here, and this is an Eagle oil can clone. Okay, obviously the Eagles were made out of brass. The Eagle 66s were made out of brass. I actually have some Eagle number 58s that are used for whey oil and stuff, and just seemed like a cool project to do, and also gives me I'm going to use it for my spindle oil, because sometimes it's a pain in the butt to get into the oilers, especially in the motor. And it's made out of aluminum with some brass pieces. Now the plans for this, you can get them off a hobby machinist website. They're in the plans section of the forum, but you have to be a member of the forum to be able to download them. And they look, you know, somewhat like this. It's just measurements and things. Now we're going to deviate from those a bit, just to bear with the stock that I have. I didn't want to buy a ton of stock, so I basically bought the tube here, and the rest I have in the shop. So this base is a little bit smaller than what they call out for. The angles are a little bit different. The length of this tube and the size of this tube is a little bit different. I think they call for 1/4 inch. I went smaller. So you can follow the plans exactly if you want. The one thing that is exactly like the plans is the valve body. That's 100% like the plans. I think the only difference I did with the valve body is instead of using the screw in the top, it's just it's a set screw instead of a cap head screw. Other than that, the valve body is pretty much exactly the same. And I also just kind of changed up spring sizes that they use in it, just to suit what I could get on hand instead of having to order them. And the check balls are still 3/16. So we'll start over on the lathe, and we'll kind of get to this and start building this, and hope you guys enjoy the video. So, alright, so I already have the tube cut to length and faced and chamfered. Relatively straightforward process, so no need to go over that. But now we need to cut our stock for our valve body here, which is where this jack screw will come in handy. Okay, so now we want our valve body to be 2 inches long, but we're going to cut it at 3 inches to have 1 inch of grab stock for the lathe. Or, and you don't even have to go 3 inches, let's say 2 3/4. Well, actually no, we're gonna go the whole 3 inches, and I'll show you why once we're done. It's because we're gonna have to put it back in this bandsaw and cut off that extra inch, and I need something to grab. So that extra inch is just grab stock. So good there. And now you can see where that the piston down feed comes in handy, where you can just lock the saw. Okay, before we start measuring it out and put this in the drill press and mark it out even, we want to have 2 nice flat faces. One so that we can measure off and do our marking out, and the other one so when we set it vertical in our drill press vise, this side will be perfectly parallel with the table. So we're going to set it up in the good old 4-jaw here, and we're going to face this. So we're going to face one side, we'll flip it over, we'll push it till it hits the end here, we'll face the other side, and then we can actually center drill it because we're going to need a small bolt in the middle for the tightening screw to hold the cover on. And then we also actually have to turn this. We have to round out the edges so it'll actually fit in our tube, and that center point here will give us some stability. So we got to indicate this in this, you know, there's a little bit of a challenge because it's not square, and you have a very, very large area on one side and a very short area on the other. So right now, basically what I'm doing is just making sure that I have clearance on my indicator all the way around, and that I can indicate this all in the same setup, which we can. So we're good to go. So let me pull the bull gear pin, make it easier on me. So what we need to do is we need to indicate both jaws. Since we have two different lengths, we need to compare each jaw to each other and get them exactly the same. Then this piece will be centered. So just like square stock, turn it until you see your indicator move back the other way. So right there, and I'm going to zero my indicator out, and then I'm going to pull the plunger back, and we're going to go to the opposite jaw, and we're going to indicate that. So 40 thousandths, so I'm just looking at my part to see which way I have to go, and we're actually low on this side, so the part has to come back to me. So we got a half this reading, so it's 10, 20, 30, 40, 50, we'll call it 60. So we got to go to the 70 mark there. Okay, now we're going to do the short side here, and same thing, turn it until it moves the opposite way, and go to our opposite jaw. And we're not too far off on that. That was just doing that by eye. So we're +4, so we have to half that reading. So I'm going to bring that down to 2. Okay, and we're going to go around and do it again. Zero our indicator. Opposite side. So we're just low by 1, so we'll have that reading. Go to our next here. Like 51 is where we change. Opposite jaw. And we're well within 0 there. Now just double check again. Zero. Just a hair off. See if I can get it any better. And I keep chasing that setting. one thousandths there, and 1/1000 there. Alright, so I'm going to call that good. So within about a half, and within, yeah, alright. So I'm going to call that square. I'm going to face this side, and then we're going to flip it around and do the same thing. I can just, if I really want to, double check these two sides here. And we're within 0 there. Alright, cool. Alright, so I'm going to face this side. Let me get a tool bit in here and just clean up the ways a little bit, and we'll have at it. Okay, so all we're going to do is face that side there. Helps if I put the ball gear in. You just got to be careful because you have such a large shelf on there. You can very easily go too deep and then dig in your tool, and it won't be fun. So we're just going to face this. Okay, that saw is all nice and cleaned up. We're gonna just crack these two, pull it out. We're just gonna deburr it real quick here. Okay, I'm gonna put it in that way till it touches. Re-indicate. I call that okay. Now we're going to face this side. I don't particularly like the finish on that. I'm going to actually just slow the feed rate down and just take another small cut, and we'll be right back with you. Okay, got a much smoother surface on there now, so we're just going to pop a small center point in there, and then when we come back, that'll help us center it up and also give us some support when we go to turn this around. So might as well do it now since we have the setup all right. And I'm using the smallest drill because this screw here is going to end up being 10/32, so just be aware of that. Okay, so now all I'm going to do is take this out of here. I'm going to deburr these edges, and then we'll go to the bench and we can do our layout. Okay, so I'm just dimensioning according to the plans here, and I already got my center line scribe. So we're going a 1/2 inch and then 1.5 inches from this end. So I'm going a 1/2 inch. On the top. And an 1.5 inches. There's nothing supremely critical about this, and I know people get all pissy with the scribing with the calipers. Again, these are dedicated scribing calipers. And 315 thousandths. 315. From that edge there. Alright, so what I'm going to do right now is go and just going to center punch these, and then we can set up on the drill press. Alright, so we're going to start drilling this, and I described some depth lines on here so I can set my stop on my drill press, and basically this one on the top here, right, we want all the way through. And then the other end of it's going to be opened up, but we'll do that once we cut the holding stock off. So right now I just want to make sure it gets all the way through. I'll use some anchor lube on drilling. Seems to work pretty good on aluminum. So this is a 5/32 drill. That's actually as deep as I'm going to get with that, and I do have to go deeper, but we have to open up this side anyway. So what I'll do is I'll get the large drill, open it up, and then I'll be able to go in with the smaller drill again and go all the way through. I got about another 1/4 inch to go. So let me take this out. The other drill, we're going to open that up to 7/32 of an inch. And I have a depth scribe line right there, so I'm going to go down to there. I'm going to set my depth stop. Okay. Don't yell at me for handling chips. It's just aluminum. I know I can get away with it. Reset my depth for this one. In that neighborhood. Okay, we're all the way through that side. Now, clean all this up. I'm going to flip it sideways and drill these two. And the bottom one is going to be 5/16. It's supposed to be reamed because that's where the piston's going to be. I don't have a reamer, but we should be able to get away with it without it. And this other one is going to be 5/32 to meet that other hole, and this is going to be 5/16 to meet the other hole. So just actually I'm going to have to bump this table up. Set my depth stop so I don't go crashing into the other side of that bore. And I'll just do both of them the same size, and then I'll open up that other one with the 5/16. So a little bit of lubage. Broke through. Broke through. So we're going to open this top one up to 7/32 by a 1/2 inch deep. Seconds. Inch deep. And this other one's going to be open up to 5/16. Till it meets the other bore, which is right there. that's actually pretty smooth. So that worked out pretty good. And so basically we have a passage from here down to below where our block is going to end, okay? And then this passage and this passage both meet this one. One of them, the top one, is going to be our spout. The bottom one is going to contain our piston and our trigger. So now what we need to do is we need to go over to the lathe, and we need to chuck this back up, and we need to round the edges so that way this will fit snugly in the actual curve of the tube, which is why we drilled these first. I'm going to tap them too. Now I'm going to tap them right now. I'll do it all off camera. This is going to be a 3/8 thread. I'm sorry. It's going to be a 3/8 thread down here, and these two are going to be 1/4 inch threads. So we'll go and do that off camera. Alright, just noticed a little mistake in the plans. This top hole here, you see it says 5/32 diameter through to the 7/32 hole. So 5/32 till it meets the 7/32, and it says tap 3/8 24. Well, that means that this hole here has to be 5/16 1/2 inch deep. I misread it as a 7/32 hole 1/2 inch deep for a 1/4 inch thread, but it's actually a 3/8 thread. So that's no big deal. I just got to take the 5/16 drill and just open that hole up there a 1/2 inch deep, and we're good to go. I just misread it. Okay, we're all drilled and tapped, and we have it set back up in the 4-jaw chuck. And now what we need to do is we need to round these edges and reduce the diameter of this so that it fits into the tube, which is why we wanted to drill and tap those holes first, so that way you're not tapping a radius surface. So the inside diameter of this tube here, and it may not be perfectly round, but we'll just go with an average. So 1.874, 1.876, 1.87071, 0.880, 72, 5, 7.5, 'So looks like the largest diameter is 1.875. The largest is around 1.869, so 1.870. So we'll shoot for 1.874. We'll try that. We'll try shooting for that and see how it fits in here. If I can get it on one to fit in there nice and snug on one side, what I can do is mark where this fits in, and then just drill the 2 holes for the trigger and the spout on the outside in line with that. You know, it's a tube. It's not perfectly round. The only way it'll be perfectly round is if you were going to bore it, but we don't need to go that far. So we just need to be careful with doing this outside and make sure we don't take too deep of a cut. And because we are kind of sticking out here, that center drill spot that I had in there is ideal for us to run our tailstock here, just for a little extra support. Okay. Try taking a 50 thousandths cut And I'm only, what am I feeding at? I'm only feeding at 5 thousandths per revolution. Let's try fitting the tube. Just about there. Just about there. Okay, we got a nice snug fit in that direction right there. So, actually you can see a scratch right here, so what I'll do is I'll drill my holes. I'll drill my holes right in line with that right in line with this line. Alright, so let me go back up to the bandsaw and we'll be able to cut this off. Alright, so now we're going to cut this to length, and which is where this little jack screw comes in really handy with things like this. So this allows you to straighten out your jaw and get a good clamp on your piece when it's really short. So again, we need 2 inches. Doesn't have to be perfect. We're around that neighborhood there. Alright, I'll buy that. good catch, wasn't it? Alright, so you can see there's our hole there. All I'm going to do now is just throw this in the forge jaw real quick. I'm going to face this end, and I'm going to drill and tap that in for 3/8. So I'm going to do that off camera, and we'll be right back. Okay, so here's the valve body. So this bottom here is going to be our trigger, and the top here is going to be our spout. This is just to hold on the cap, and that is to allow us access to put in the check ball, and then the piston is going to be in this one. Okay, so now what I'm going to do is I'm going to mark out the tube, and we'll drill the 2 clearance holes to fit the nuts that are going to fit this. I got a package for you. What do you mean you don't want to open it? Come on, open it. I guarantee it'll be a blast.